Hello students, welcome to the channel. In our continuing series Basics Explained, we look at the fundamentals of various topics that you're likely to see on SAT and ECT. Today we are looking at an important math topic, how percentage change relates to multipliers. I'll explain what I mean by this as we go along. So what is percentage change? Percentage change is the increase or decrease in a certain number by a certain percentage. For example, let's say I want to increase 20 by 25%. So if I want to increase 20 by 25%, I would write that as 20 plus 25% of 20. Since I'm increasing 20 by 25%, I would add 25% of 20 to 20, which is 20 plus 0.25 into 20, because 25% is 25 over 100, which is 0.25. And 0.25 into 20 is just 5. So I get 25. So 20 increased by 25% is 25. What if I were to decrease 20 by 25%? I would do the same thing, except this time I would use a negative sign, 20 minus 25% of 20, which translates to 15. Now, if you notice here, this expression, where I have 20 plus 0.25 into 20. If I take 20 common, I can write this as 1 plus 0.25, which is 20 times 1.25. So if I were to increase 20 by 25%, that's the same as multiplying 20 by 1.25. So 1.25 here is the multiplier that I need for an increase of 25% in a number. Now, it's interesting because 25% increase is represented as 1.25, right? Let's look at the decrease. If I were to look at the decrease, then I would say 20 minus 0.25 into 20, which is 20 times 1 minus 0.25, which is 20 times 0.75. And you can see that here I can notice that a 25% decrease in a number is equivalent to multiplying the number by 0.75. So this is the multiplier that I use when I decrease a number by 25%. And you can see that this would be repeated and you can come to a pattern. For example, let's say I want to increase a number by 10%. So let's say the number is A. So I write A plus 10% of A, which is A plus 0.1A, which is 1.1A. So increasing a number by 10% is equivalent to multiplying the number by 1.1. But with 20%, it's equivalent to multiplying it by 1.2. 27%. A plus 27% of A, again, A plus 0.27A, which is 1.27A. What about 4%? A plus 4% of A is A plus, remember, it would be 0.04 now, because 4% is 4 by 100, which is 0.04. So that's 1.04A, right? So I observe a pattern, the pattern being that if I have any percentage increase between 0 to 9, I simply can write the multiplier as 1.0 and that digit. So if it is 2% increase, multiplier becomes 1.02. If it's a 7% increase, the multiplier becomes 1.07, and so on. And for any number between 10 and 99, I can simply write the multiplier as 1 point that number, right? So if it's 20%, the multiplier is 1.20. If it's 27%, it's 1.27. So that's the pattern I notice when I talk about percentage increase. What happens with percentage decrease? In percentage decrease, the multiplier works in a different way. So when there's a 10% decrease, we can write it as a minus 10% of a, which is a minus 0.1a. And a minus 0.1a is 0.9a, right? For 20% decrease, you'll get 0.8 as the multiplier. For 27%, you will get 0.73. And for 4%, you will get 0.96. A minus 4% of A, which is A minus 0.04A, and that's 0.96A. So here again, we see a pattern. If I have a decrease between any number, decrease of any number between 1 and 99, then my multiplier becomes 1 point, whatever is left here when I subtract that percentage decrease from 100, right? So for example, if I subtract 4 from 100, I get 96. Sorry, this was 0.96. If I subtract 27 from 100, I get 73. So a 27% decrease would be 0.73. If I subtract 20% from a number, I would get 100 minus 20, which is 80. So 0.80 is the multiplier, and so on. So when you practice and you get familiar with this, this would come naturally to you, and you would be able to use this technique to get percentage increase questions really fast. So let's do a sample question. The quantity K is reduced by 20% of its value. Which expression is equivalent to the resulting value? So I'll solve it both ways, but let's just try what we learned right now. 20%, right? So the multiplier would be 0. And here I would write 100 minus 20, so 0.80. So the quantity K reduced by 20% is 0.80 K. If I were to do it by the longer method, I would say K minus 20% of K, which is K minus 0.2 K, which is 0.8 K. So I get the same result. It's just that when you are able to look at the number and look at the pattern, then you can do it within seconds. Okay, let's apply this to a word problem. The length and breadth of a square are increased by 30% and 20% respectively. The area of the rectangle so formed exceeds the area of the square by how much? So let's say the length and the breadth of the square, so they will obviously be equal. So let me just call it L. So the length is increased by 30%. So my new length would be 1.3 L, right? And my new breadth would be 1.2 L again, because the length was the same. So I've increased it by 30%. So using a multiplier of 1.3. And for the new breadth, multiplier is 1.2. What is the area of the square? It is L square. What is the area of the rectangle so formed? It is 1.3 L times 1.2 L, which is 13 into 12. So that comes to 1.56 L squared. So the area L squared has become 1.56 L squared. And just by using the concept of multipliers, I can see that that would be an increase of 56%. So you see, it becomes really quick to solve these kind of questions if you know that certain percentage increase can translate to a certain multiplier. And similarly, a certain percentage decrease can translate to a certain multiplier. It is faster than to just look at the change and answer the question without having to use the percentage change formula or the percentage increase formula. Right, so hope this video was useful. If there's any other concept whose basics you're looking to learn, let me know in the comment section and I'll try and upload it. Hit like and subscribe to the channel and share this with your friends. Help the channel grow. I'll see you all in a new video soon. Take care. Bye-bye.